So does Wi-Fi radiation cause health problems? This would be the routers in schools and in buildings and practically everywhere we go. Does Wi-Fi radiation cause health hazards? This is a huge question. We're going to look at the fairly narrow area of mechanisms. Is there something in the story of quantum mechanics that could give a mechanism for damage from Wi-Fi? Wi-Fi is all about the electromagnetic spectrum. So let's take a look at the electromagnetic spectrum. The high energy side is the small short wavelengths, is high frequencies, short wavelengths, gamma rays, X-rays. The Goldilocks zone of the electromagnetic spectrum is visible light. Visible light, of course, comes from the sun in massive amounts. Visible light runs our planet. Visible light is the frequency which impacts on chemical behavior without causing molecular destruction. The fact that visible light is visible is not a coincidence. Visible light are those frequencies which can impact on molecular behavior and is the frequencies that can be seen by our eyes. There's a little bit of a deception in this graphic. This is a magnification off of the big scale. If this was done properly according to scale, this would be a line which would not even be visible with a microscope. Going to longer wavelengths, lower energy, we get to infrared radiation, and then we get to microwaves. Wi-Fi is in the low energy end of the microwaves and then into the radio waves. Microwaves are extremely low energy. They're like crazy low energy compared to visible light. A photon of green light has 1,000,000 times more energy than a quanta of energy from microwaves. So I want to turn our attention to this graphic. There's no x-axis on this graph. The y-axis doesn't have any numbers. There's no numbers on the y-axis. Let's put carbon on this. Carbon has 6 electrons. There's 2 electrons in the first energy level, 4 electrons in the second energy level. The third energy level can have 8 electrons. In the case of carbon, it doesn't have any electrons in that energy level. Carbon, of course, being atomic number 6, has 6 electrons. If the carbon is excited in some way, like with maybe a flame or a spark or something, this electron can jump up to here, and when it does, it will absorb a photon of green light. And then, probably unstable at the higher energy level, the photon will fall back down and emit that same photon of green light. So there's a big energy difference between this. We have 4 electrons in the second energy level. We want to magnify that energy level. So we've got 4 electrons, but if we magnify it, we find out that there's 2 s electrons and 2 p electrons. And these are not the same energy level. And furthermore, the 2 p electrons can either be paired or not, which gives us even more energy levels. In the 1930s, Linus Pauling looked at the structure of methane, which is symmetrical, and said, wait a minute, these electrons must be equivalent. And he adds to the story the idea of the sp3. So the s orbitals and the p orbitals can become the same thing, and they're equal, and he called them the sp3. He added the vocabulary to the story of quantum mechanics and came up with sp3 hybridization, which is yet a different energy level. And then the sp2 hybridization, which is in double bonds, has 3 that are equivalent. And of course, the p electron, the pi electron is the perpendicular, is the one that's perpendicular in double bonds. And then the sp orbital, which would be found in acetylene, is yet a different set. So the point being that these are all different energy levels. And these are energy levels just like the first energy level and the second energy level, and there's a quanta of energy between them. And I want to back up a little bit and look at this big graph. This is a representation of a little line on here, and if this distance was put on this line, it would be a line that would be so small you couldn't see it with a microscope. So there's approximately 1,000,000. It's approximately a magnification of 1,000,000. There's a quanta of energy between each one of these energy levels. There's a couple of things I want to add to this. One of them is that the the quanta is very specific for what it's going to do. And the second thing is that we're looking at carbon here. All atoms have this same kind of stuff in their outside energy level. Other atoms being especially iron. Iron's really complicated. Phosphorus, zinc, potassium, calcium, all of them have this same kind of stuff in the outer energy level. So, does Wi-Fi cause health problems? I mean, I don't know, but these transitions look to me like they could be within Wi-Fi, and I think that we see a possible mechanism here for damage from Wi-Fi. And then the last point would be that the frequencies are not the same, and if we're going to wonder about damage from Wi-Fi, we really need to look at the frequencies separately.